The U.S. Department of Energy and Calpine are working together to increase the use of renewable energy. This slideshow was produced by Frances Negrón Martínez, a high school summer student intern from Puerto Rico, whose project at the Berkeley Lab was to generate outreach materials to educate the general public about geothermal energy. This presentation will explain the wastewater treatment process used to increase geothermal power production at the Geysers geothermal field. Here you will see the process of how wastewater is treated, how the treated water is used to enhance geothermal energy production, and how the energy produced is used to provide electricity to the homes, businesses, and industries of Sonoma, Lake, and Mendocino counties, as well as a portion of the power needs of Marin and Napa counties. This house is known as the McDonald Mansion and was built in the late 1870s by Colonel Mark Lindsay McDonald, the first owner of Santa Rosa's water company. Homes, businesses, and industries provide the wastewater for the treatment plant. The Laguna Wastewater Treatment Plant is located in Santa Rosa. The wastewater from the cities of Santa Rosa, Rohnert Park, Sebastopol, and Cotati form the Santa Rosa Subregional Water Reuse System. The Laguna Wastewater Treatment Plant uses 3 steps to treat wastewater. Step number 1 is called primary treatment. The wastewater first passes through quarter-inch screens that remove plastic, wood, and paper. Then, sand and gravel is removed in the grit tank. The water then goes to the primary clarification tanks, where the lighter material, grease, floats to the surface and is skimmed off, and the heavier material, sludge, sinks and is transported to the digester tanks. This is the inside of the plant. Here is our group under the primary clarification tank. The sludge is processed in 4 1-million-gallon anaerobic digester tanks. The bacteria in the digesters create methane gas and CO2 by breaking down the solids over a 25-day period. The digested sludge is used as fertilizer. The cogeneration plant is powered by the methane gas that is produced in the digester tanks and produces electricity for the rest of the treatment plant operations. The digester tank methane supplies a full 1/6 of the fuel needed for the plant generators, which power everything from the lighting to the air and water circulation pumps. The Laguna Wastewater Treatment Plant has been harnessing digester gas to produce power since 1976. They also use solar energy resources to power the treatment plant. This is a heat exchanger. Hot water from this cogeneration system is used to keep the digester tanks at an optimal 98 degrees Fahrenheit. In the second step of the treatment process, the water goes into aeration basins, where the wastewater is injected with air to stimulate the growth of microorganisms. This process lasts 6 to 8 hours. The microorganisms are removed in the clarification tank, and some of the bacteria are cycled back to the aeration basins. Here the water is going from the aeration basins to the clarification tank. This is the secondary clarification tank. Here the water is clearer. There are some pipes that vacuum the organic material, including bacteria, that sinks to the bottom of the tank. The final step in the treatment process is called tertiary treatment and disinfection. The water flows through a 4-foot bed of coal to filter out suspended solids before going to the disinfection area. In the disinfection area, ultraviolet light destroys the DNA of the bacteria and viruses, thereby eliminating the means of their reproduction. This expensive light bulb is for the UV treatment. It has an operational lifetime of 10,000 hours. The water has to pass within 2.5 inches from the UV light in order to destroy the DNA material. The fountain represents the clean water generated after passing through all the steps of the treatment plant. The pipeline that transports the water from the Laguna Wastewater Treatment Plant to the geysers is 41 miles long and climbs 3,320 feet in elevation. The Llano pumping station, located next to the Laguna Wastewater Treatment Plant, pumps recharged water up from the treatment plant facilities on Llano Road to the Bear Canyon pump station. This portion of the pipeline is 30 miles long and climbs 380 feet in elevation. Some of the extra water that is cleaned and disinfected is also stored here. At the Bear Canyon pump station, there is a 500,000-gallon reservoir located under the building. These are the pumps and the motors at the Bear Canyon pump station that pump the water up the hill. This water goes to the Mayacamas pump station, and after that to the Pine Flat pump station, and afterwards to the terminal reservoir. The pipeline passes through the now uninhabited mining camp of Pine Flat. In 1870, there were quicksilver mines located nearby. In 2004, there was a fire that burned the shrubs and trees. The pipeline is buried 4 feet below the ground surface and goes all the way up the hill. On the way to the terminal reservoir tank, the pipeline also passes by vineyards and the Audubon Society's Mayacamas Mountain Sanctuary. The terminal reservoir tank has a capacity of 1 million gallons. The pipeline delivers 12 million gallons of recycled water to the geysers every day. From the terminal reservoir tank, you can see 2 of the power plants at the geysers. It's also possible to see live fumaroles. Here is a map of the injection pipeline network for the geysers. Note that there are 3 main sources of injection water: the reclaimed water pipeline from Santa Rosa, the effluent pipeline from Lake County, and steam condensate from the geothermal power plants. At the geysers, there is a network of over 120 miles of injection lines and over 35 injection wells. Calpine has about 15 miles of piping to about 16 injection wells dedicated to receiving the water from Santa Rosa. In this shot, there are 2 production wells and 1 injection well. This is an animation of the injection and production process. Cool water is flowed into an injection well, typically with depths of 8,000 to 10,000 feet, and into the geothermal reservoir. The fluid is heated by the hot rocks to the point that it becomes steam. The steam flows through the fractures and eventually is tapped by 8,000 to 10,000 foot deep production wells, which bring the steam to the surface and carry the steam to geothermal power plants through a network of steam lines. One issue associated with a large-scale injection of water at the geysers is the generation of induced seismicity, or very small-scale tremors. Most of these tremors cannot be felt at the surface. This is a downhole seismometer that is part of a network that monitors the location and magnitude of these micro-earthquakes. There is a solar panel to power the unit and an antenna that transmits data back to Berkeley. In the northwest geysers, Calpine is drilling new wells to expand production from deep, hot rocks. This is a picture of a drill rig at the well Wild Horse State 34. On July 1, 2010, it was at a depth of 4,200 feet below the surface. These are 5 of the 9 wells that supply steam to the West Ford Flat power plant. Here, geochemists were collecting well samples of steam and associated gases. This is a model representing how the power plant works. Inside of the West Ford Flat unit, there are 2 turbine generators that each generate 13.5 megawatts, producing a total of 27 megawatts. This unit is supplied by 9 wells that provide 424 kilopounds of steam per hour. The turbine shaft rotates at a rate of 3,600 revolutions per minute, and the inlet pressure of the turbine for the steam is 100 psi. The control room is staffed every day, 24 hours a day. At the hydrogen sulfide removal unit, the hydrogen sulfide is converted to sulfur using the Stratford process. The final step in the wastewater to energy generation process occurs in the cooling tower, where the steam that goes through the turbine is cooled down to be injected in the earth again. The combined effect of the Santa Rosa and Lake County recharge water injection projects is an increase in power production at the geysers of around 140 megawatts. In 2010, the geysers celebrated 50 years of commercial geothermal electrical power generation. With the addition of recharge water from the city of Santa Rosa and Lake County, the geysers is expected to produce clean geothermal power for many years to come. We thank the financial support of the U.S. Department of Energy and the National Science Foundation and the assistance of Calpine and the city of Santa Rosa in the production of this video.